All right, welcome everyone to this Hashi Corp training on Terraform. This will be a approximately 4-hour session with live demos and demonstrations and examples that you'll be able to do. The initial environment we're using for this is going to be Azure, but what you're going to learn would be also equally applicable to AWS. We can potentially do a repeat of the session in the future. We'll see how that goes with HashiCorp, and maybe the next time it might be on a different cloud. But one thing to note is that the purpose of the Slack channel, which you all should have received an invite to via email, is to ask questions. We do want to limit any sort of questions verbally just because of the number of people that will be on this, but possibly towards the end we'll have some time for general Q&A on the product and things like that that you can ask verbally if needed. The other thing to note in the Slack channel is that there'll be a list of credentials there. So if you were also on the invite, which all of you should be, you'll see some credentials. Those are just to access the Azure environment that HashiCorp has set up for us. But if you have your own Azure environment, you're able to use that too. You just need to, get the proper tenant ID and subscription ID, I think, to make all that work. And by the way, correct me if I'm wrong on that, Chris, that they can also use their own tenant if they want.
Yeah, if they need to use their own tenant, they're going to have to create a service principal.
Okay.
I've done that in the credentials, so it will be easier to use what we've got because it should just work out of the box. But for people that are advanced and can work around creating their own service principal, they should be able to make it work as well.
Okay, yeah, so if you have trouble with that, I think we could probably ask that in the chat if they want to create their own service principal. Is that fair?
Yeah, that's fine.
Okay, yeah, I don't know who's, just making sure. So if you don't have credentials, by the way, for some reason, make sure you post in the chat, because I did think I saw this meeting was forwarded, which it shouldn't have been, to a couple people, so you would not have received then anything that I'm talking about here. So with that, I'll pass it over to, I guess, Chris to get things started.
Great, thank you very much. So let me share my screen. So as we mentioned, just some housekeeping stuff. Slack is where we want to ask questions. Training is the channel we'll be in mostly. My expectation is that, so we've got several people that are on here that are helping me today from my side. So it's going to be Ryan Cassidy, Kevin Corbin, Justin Lin, and Sean Cervantes. So it's very likely, start the chat in your conversation training, and we'll probably go to a direct message with them to continue the conversation, because I expect it's going to be really chatty in here. There's two things of note in the channel. First off, these slides are pinned here to the subject. So if you go to this, you can see everything that we're doing today sitting up in a public GitHub, and it's all marked down. You're welcome to print this, come back and review it later. It will be accessible on here, so you guys have full access to this content that I'll be going through today. As we go through this, there'll be I will talk about some concepts, and then we'll have a set of exercises. So you'll be able to actually perform these exercises. The exercises are all done in the format where I give you tasks to perform and then links to documentation. So you guys should be able to go through there and use a workflow that's very similar to how I would expect you would do it in the real world, perusing the documentation and then using that to build up the examples. Pay special attention to those hints because they're there for a reason, to prevent you from falling down some rabbit holes. And hopefully if you have any questions, again, just ask that out in Slack. And let's get going. Let me see if I can make this full screen. Enter full screen. Cool. And let's get rid of these toolbars. Cool. Well, let's just get going with this. And let me just going on my phone as well. Cool. So what are you guys at today? So this is a training on Terraform. It's intended as an introductory training to Terraform. And specifically, we're going to be using Microsoft Azure. The concepts in Terraform that we're going to go through today are equally applicable on other cloud providers. So if you guys want to go use this knowledge on AWS or Google or even an on-prem solution like VMware, that will all work. As we'll talk about today, Terraform is designed to be pluggable. We're a language, so that you should be able to come in here and use the concepts, but the actual names of things you're managing will change. And we'll dive a bit deeper into that in a bit. And not going to the next slide. There we go. Cool. So the slide deck, again, here's the link to the slide deck. It's also in the chat on the training. So if you want to follow along on your computer or you want to go back and forth, please jump over here, look at the slides. All of the exercises, like I said, are in the deck. So as you want to look at those, this is the place to go. So introductions, who am I? So I am Chris Madison. I am a Senior Solutions Engineer for Hashi Corp. I've been here about 2 years. I am dedicated towards our cloud and SI partners. What that means is that my job is to help provide enablement and training, such as what we're doing today. We also do certification, and so we've been working with your team. We did the first pass at what was our sales and technical sales certification, and now we're working to move further along towards the higher level product certifications. Will not be certified at the end of the call today. This should help build the skills that you need to move towards being certified on Terraform. And the expectation here is that in the coming months, we'll have a certification exam that will make available to Capgemini to take. And so like I said, this won't cover everything, but this will give you a really good start on what to learn. So I like this slide in person. This slide doesn't work as well in a virtual training. So I don't know if there's a easy way to do this. Maybe I can do this from Slack. And no, I don't have the poll included. So normally I would ask everyone what their existing experience is. Since I don't have an easy way to do that here, I'm going to skip over that. But like I said, this is mostly for people that are new to it, but even people that have used Terraform in the past, I expect you'll find something useful here. Cool. Table of contents. These are all the chapters we're going to go through today. I'm expecting this is going to take us about just under 4 hours. If we don't get through all of it, we'll still get through the good chunk of why Terraform. And then we've got a bit of Terraform Enterprise at the end, which I think will be nice to see if we can get there. So let's talk about just provisioning a VM on Azure. So you think about what we need to have the information for that, right? It's a virtual machine. I need to know the operating system that I've got. I need to know the size and location of what I want. Here we go. And so all of this information I need to input in some way to actually go create that VM. So I could do it through the UI, which is one way to accomplish this, but we think about this, it's going to be slow. It's not something that's going to scale. And we think about the terms of DevOps and infrastructure as code, it's not something that's likely to be done reliably. If I have 100 different people go create a VM through the portal, I'm likely to get 100 different ways that actually gets done. So we actually see going through the portal and accomplishing this. The next method we have, so Azure provides the Azure Resource Manager templates, which is their version of infrastructure as code. If you guys are familiar with AWS, they have something called CloudFormation. The clouds all have some equivalent that's native to them. And for Azure, it happens to be a lot of JSON. It's nice for computers to read, but it's not as nice for humans to read. And of course, the last method, and the one we're going to be talking about today, is let's provision with some Terraform. So we see this is versus the ARM templates here. In JSON, it's a lot less code, and it's a lot easier to read to understand. You don't really have to know what Terraform is or what it's doing to look at this and be like, okay, it's a virtual machine. This is the name, the image, the VM size, the location, username, password. I get what is going on here. So let's talk about what Terraform is. It's really, to some degree, executable documentation, right? We're infrastructure as code, but we're also designed to be something that a human being can use, and that's available to anyone to get into and understand without needing to understand the language intimately in order to actually be able to at least understand what's going on. And then, of course, we're designed to be reusable as possible, in that we want to make sure that you're not going through and copy and pasting and writing a bunch of unique stuff that causes drift over time, and then hopefully you're able to use the least amount of code that you have to write and then reuse it over and over so you have consistency. So what's infrastructure as code? Think about this. This is a topic that goes far beyond just Terraform. We are one of the many infrastructure as code tools, but we really is part of this overall DevOps pipeline concepts, in that we understand that anything that's done manually, that's done by a script, is going to lack consistency. The best way to have that consistency, and I've got some background noise, so if I get everyone mute if possible, it'd be super helpful. So the consistency that infrastructure as code provides us is that I can do one thing and then repeatably know that I can do it again. And then moreover, I can put it into version control, and then I can actually understand when something changed, who changed it, and ideally with a decent commit message, why they changed it. And then you can use my favorite Git command, which is git blame, if something actually does happen, and look back at a specific line and be like, why did that change and who did it? And I know immediately. If you think about the alternative, if somebody is doing this with a script or is doing this by hand, hunting through log files to try to understand why that change occurred is difficult, if not impossible. So let's think about what infrastructure as code allows us to do. We provide codified workflow for everything that we do. We can update the existing infrastructure in a way that we understand instead of manual, and then bring it to a stage where we can still recreate it even though we've had change occur. We can test changes because it allows us to understand where we currently are and where we want to be, so we can know in advance before we make the change what's really going to actually occur. Which, we think about something like a script that goes out there, we might try to conceptually understand what that script does, but we still have the risk that it might do something unintended. With infrastructure as code, and particularly with Terraform Plan and the dry run mode, I have a much better understanding what's going to happen before it does. Then I can integrate this with application code workflows. And this is important, right? If you're just using Terraform by itself, which is actually how we're going to do it today, and you try to take that out into production, you're going to be in a really scary world. And that I'm not going to have that confidence that I know what's changed over time. So what we want to push and we want to ensure is that if you're going to use Terraform, you're going to use any infrastructure as code technology, it should be part of a pipeline, it should be part of a workflow, and everything absolutely should be in version control. It makes reusing this code much easier. Collaboration is really going to accelerate the ability for your teams to be successful. It allows us to enforce policies and organizational standards. So I can come in here and understand, hey, this is the way that we need to do it, and I can enforce that via code and looking over what we actually write to ensure that it's compliant with our policies. And of course, collaboration between teams. Think about this as infrastructure as documentation or executable documentation concept. If I need to tell somebody how we do it, what better way to tell them than what's the authoritatively correct way, because it's the way that provisioned it in the first place. So let's think about other tools that are out there. You guys are probably familiar with things like PowerShell, DSC, Chef, Puppet. These tools are all really powerful, but they're generally designed to work inside an operating system. A lot of them have the ability to touch some API addressable infrastructure, but it's not really their core component tendency. Then we have the native cloud provisioning tools. Here you can guess who brand A and brand G is. But each of these has their own tool that's specific for that one cloud, and works just for the things that they need, and maybe one or two other things where they've slightly expanded it in the last couple of years. And so we think, what does Terraform do? Well, it gets us out of this sort of situation here, right? Do you want to be JSON or you want to be YAML? I'm sure all of us that have troubleshoot these situations before, trying to understand like, why doesn't this code work? Kind of understand this conversation, this comic here. So let's look at Terraform versus Arm and JSON, right? And we want to see how things can be easier to understand. So I want to go in here and say, hey, let me understand what this pilot server name is. Much more annoying to do this in JSON than how we can do this relatively human readable in the HashiCorp configuration language. And this is actually not even the craziest example. There's a lot of times where we see that the equivalent ARM template is significantly longer than the Terraform code to do the same thing, because we're able to reuse a lot of what we're doing and making smart choices about how we tie things together. So one of the things that people often think about, right, is that, hey, well, the native tool is always going to have the best support, right? And the third party is always just going to be a bolt-on. And they're not going to have the same level of love that the native tool will. And what's interesting, and is really starting 2 years ago now when Corey Sanders, who's Vice President at Azure, posted this, right, is that we have really deep ties into Microsoft. And they've made a huge investment to the point now that they have dedicated staff at Microsoft to ensuring that our success and that our customers are successful with Terraform. We work together on the Azure RM provider to ensure that milestones are met, and we get the early preview access into what's going to be released. So when things like AKS was released, we actually had support before ARM templates did. We've now reached that point with AWS and Azure and Google where we're collaborating with them so tightly that we actually are exceeding what their native tools are doing. We're getting there faster and we're doing it better. And so you have to understand that Microsoft really wants us to succeed, and it's not something where we're doing this game on our own. At the end of the day, you think about with all the cloud providers, right? They make $0 on their own native tools. They're things that they operationally have to offer because people are asking for it. But Microsoft makes no money when you use ARM. Microsoft makes money when you deploy resources. And if you're able to deploy those resources faster and have a better experience by doing that with Terraform, they're more than happy to support you. All right. So why Terraform and Azure? So one of the things that we get here, right, is like the multi-cloud infrastructure and hybrid infrastructure. And that's really generally true of all of our tools. We like to be that company, right, that enables you what we call workflows, not technology. And what we mean by that is that if you're using Terraform to provision, and then some of our other tools like Vault for security and Console for networking, right, we're able to decouple where you choose to place an application from the rest of the underlying infrastructure. So you can make technology choices around what the best tool is, not where you happen to already have all of your data sitting. Right? And we can think about this. Well, if I have all of my data in AWS, and I would like to use an Azure service, but it's too difficult for me to copy that data out of an S3 bucket and move it over to blob storage and then maintain that in a replicated fashion. Well, we can with Terraform provide you one way in order to provision to both sides. With Vault, one way to connect and provide authentication between both these, and with Console, one way to discover and provide the networking across all of it. So multi-cloud really is our bread and butter, and that's where we shine. But that doesn't mean that that's the only reason to use us. And again, as we're to think about the Microsoft investment, it's not like Microsoft is investing in us. It's not like AWS is investing in us because they want you to be multi-cloud. They would gladly love to be the only cloud out there. There's other advantages that we have. But of course, if anyone's multi-cloud or hybrid infrastructure, like that's T-ball for us, and we're always going to be the best choice. So if you need to migrate between cloud providers, and this is something the IT director of Marriott provided a quote for us as one of our case studies, in that he really appreciated about Terraform was that, like, previously he was trying to hire separate teams for AWS and for Azure. These had different tools and different workflows they needed to manage. There's different ways that those tools operated. And now with the migration to Terraform, they're able to do it all in one tool. And so they don't have to go out there and have these two separate teams. They have one team to manage all of their cloud infrastructure, and that makes it easier for them to hire, and it gives them greater efficiencies. We've also seen other times, particularly around Azure, where people have a hard time hiring skills for people that are skilled on Microsoft, on ARM templates. And because of that, they end up spending a long time or spending a lot of time to train people on ARM. Well, they found out that, hey, if I want to go hire somebody who knows Terraform, I can do that much faster and much easier. And the upshot is they might have learned Terraform at AWS, but they're able to move that workflow and they move those skills over to Azure very quickly. At the end of the day, this is really what gets us a lot of people wanting to use Terraform, is the fact that they get to where their end goal is quicker, right? That's what they need accomplished, is actually getting stuff provisioned, not building the best tool ever. We're able to do it faster. We're able to be more efficient, and this comes down to just writing less code, right? The more that you're able to reuse code, the more they're able to use loops and counts and modules, the more that you have consistency among what you're doing. The interpolation can tie things together. We can be multi-threaded as we're doing it. That's all more greater efficiency, and that pays off the bottom line of the company. And then, of course, there's risk. All right, if we are doing things where I have a thought of what might happen, and this is anytime I run a script, right? If I'm running Ansible to go provision my infrastructure, I probably have a good idea what I hope that Ansible script is going to do. But until I actually run it, I don't know what's going to happen. The ability to know in advance what matters or what's going to happen is a huge benefit. So let's talk about a bit of intro to Terraform. How Terraform works. We're broken into two parts. Core, which is the Terraform language itself, our ideas of interpolation, how we tie the different components together, the building the dependency graph, all of that we're going to go through. And then we have these pluggable providers. The cool thing about that is that somebody could write a provider for literally anything. There's hundreds of them out there today. So it's not just AWS, Azure, Google. It's also things like Kubernetes, F5, right? Datadog. Any of these things that I need to manage, I can manage with one single language. And a huge benefit to that, right, is we think about, hey, what do I need to do if I'm going to deploy my application? Well, deploying the components that are up there in the cloud is only one piece of that deployment. What I also need to do is then go tie that into my monitoring solutions, into my application management solutions. How can I do that if my deployment language, my provisioning language, doesn't support talking to those other systems? Well, fortunately, Terraform does, and you can always just write your own provider and plug that in if you want to do something new and cool. And we have lots of people where in the community, they go out there and do that. Being an open source tool, being a pluggable tool, means that we allow people and allow the community to really push the tool forward, and that's paid dividends in terms of the support that we've got out there. So let's look at the anatomy of a resource here, right? So we have top-level keywords. In this instance, it's resource. We'll see a few other top-level keywords as we go through today. Then we have the type, which is the actual type of resource that we're managing. These will always begin with the name of the provider. So for the ones we're using today, they'll all start with Azure RM. Then we have a name. That's a name that's unique within Terraform for that type. That's not the name of what actually gets provisioned. So if I was going to make a resource group, for instance, this name is not what gets provisioned. There'll be a parameter for a name as well of what actually gets provisioned. The nice thing about that is I can have that parameter, the name of the resource group, be something that's dynamic. And we'll see that today when we look at using a random ID in order to ensure that we have uniqueness. Well, I can have this be a much more human readable with my code. And we'll see where we use that Terraform name in a bunch of places in order to build our resource graph and pass information back and forth. So let's look at the workflow. This is something you guys will do a lot today. So we've got the same core and providers. First thing we do is we do a Terraform init. that really prepares Terraform to be ready to run. So we'll see here in a bit, there's dependencies that Terraform has on these providers that we need to download, as well as potentially from modules and the backends. And the init gets that all set up. It's not something you have to run every single time, but it's something you have to run before you can run Terraform plan or apply. The Terraform plan is what actually goes out there and reads the Terraform code and then compares that with the current state and determines what would I do. And this is one of the big benefits of Terraform, right, versus using a different tool, is you've got that point right before you go and deploy where we're going to tell you exactly what we're going to change. Be like, hey, all of these resources look great. We're not going to touch them. These resources, something changed on them that we need to fix, and these ones didn't exist before, so we have to go create them. It will tell you that clearly in that plan stage. And the apply is where we actually go out there and make those changes. So let's talk about configuring these providers. You see here's another top-level keyword, provider. So we allow you to configure these within the code themselves, and so we can lock these things down to particular versions if we're concerned about that. We can also potentially pass in configuration information for it to actually go out there and talk to the provider. Do not ever do this. We really, really want to avoid this practice of writing our secrets here into the code. The problem is all of our code, remember, should be in version control. And if you commit these kind of secrets in the version control that somebody else is able to see, they could use those secrets to gain access to your cloud providers. There are much better ways to do this, which are much safer. So while I'm showing this example here, this is the way not to do it. Please do not do this in your code. Here's some better ways to do this. The cool thing about Terraform, for most of the providers, if there's a way that the native the tools work already locally on the system that Terraform is running on, we will look for those. So on Azure, you can simply do an AZ login, or you can export your service principal information to environmental variables. Both of these keep all of the actual secrets out of your code entirely, and will just work. Today, we're going to need to do none of these because we're going to be doing everything in the Azure Cloud CLI, which is already authenticated with Azure. So let's look at creating a resource group. So we can come here, and I've got a resource for Hashi training. And you see, we talked about this before, the top level keyword, and then the actual resource that we're creating always starts with the provider, and then it has the resource, my internal name, Hashi training, and then the parameters. For in this instance, I need to have name and location. If we go and we look at, if you go look at the documentation site, you'll see the requirements, and it'll always show you the required parameters and the optional parameters that are available for this. So we'll spend a lot of time on the doc site today. It's a great resource. Every option starts with a great example that should work, and they'll show you the required parameters, the optional parameters, and whatever outputs you can get from it. So let's look at creating this with a random ID. So this is a workflow that I really like for creating reusable Terraform code. And I highly recommend doing something similar to this. There's some other ways to do this. Some people like to create a variable in which they'll pass in a mandatory variable, something like a prefix, that they'll include in all of the resources they create. I usually use random ID so I don't have to pass anything in. This is one of the hints, by the way, in the first exercise is to do this. So I highly recommend doing this. And so let's copy this because I think the next is demo. And you'll see here, and we'll talk about this more later. You see I'm going to create this random ID, which is just creating a 4-letter string. And then this is where I'm actually using it. I'm going to pass in the hex value of that string into the name path. So the actual name that gets created for this resource group up in the portal is going to have that random ID in it. If I ran this code a whole bunch of times, I should end up with different values. So let's actually go look at this. Training. So if you guys logged in the Azure Portal before, it's just portal.azure.com. The credentials document that's in Slack will have your login. Please use only your own login. We're going to be doing everything today from the Cloud Shell. It's this little button up here at the top. And click that. It'll kick up the Cloud Shell. I recommend using Bash, this PowerShell as well. Terraform's pre-installed on both, but it's a little quirky on the way they set up in PowerShell. You also, if you prefer full screen, you can go to shell.azure.com, and this will give you a full screen version of the Cloud CLI. So, thing here, see this? Terraform comes pre-installed. Again, this gets back to how close the relationship we have with Microsoft is that this system that they've baked in and forced everyone to have as part of their Azure portal already has Terraform in there. Already the latest version. You don't need to do anything to have Terraform up and running as shell so we can work today. So let's make a folder. Let's go into this folder and make a main.tf. We'll talk about the different naming conventions for your files later, but the first file people normally create main.tf. Okay. One of the other cool things, actually, by the way, so the Cloud Shell also has VS Code in there. You can use that, and it's got the Terraform extensions built in, so you can see it does the highlighting for you. So I can create this here. I can save it, close the editor. Got this. Now we can do an init. And of course, I broke something right off the bat. Oh, I wrote this with the wrong curly brace. Cool. So now we've done an init. We see as we pulled down the two providers, the Azure RM and Random. Notice when I did this, right? I don't actually have a provider stanza in here. What I could have done is I could have said provider Azure RM, and then said something like gen equals, equals, and then I say greater than 1.0, something like this, and then ensured that I had the correct version. I can put, as you see, I can do either equals exactly, or I can do greater than less than kind of logic for what I need that to be. This is usually and often a best practice, and you'll see this very commonly done in a lot of Terraform code, but it's not required because we will look up, like I said, at the beginning and look up what the provider is. And that hopefully shouldn't have broken anything. Cool. And so now I can do a Terraform plan. What did I break on here now? Just part of the training I didn't test because I was like, this is just going to work, right? Missing a byte length. Yep, that's why. I wrote this by hand. So we actually give some decent error messages on what I was missing. Cool. So we see the plan here. I'm going to create this resource group, and I'm going to create this random ID. But I don't actually know what this stuff is going to be, like the IDs of the resource group or the random ID that's going to be created, until I actually do the apply. Cool. And now we've done the apply. And so now I can actually see Terraform state, what got created. So here's my random ID for the project name that was created. Here's the hex version of it. And you can see how that got inputted here into the training workshop. If I look back in Azure and I go with my resource groups, you should see that now exists. So we've gone through here and we've created it. Cool. So let's get you guys into the Azure Portal and the Cloud CLI. So this is our first exercise. Should be pretty easy to do. What we want you to do is to log into the Azure Portal and to kick up Cloud Shell. So I'm going to give everyone a few minutes to do that right now. If you have any questions or you're doing it, please hit us up over Slack. If your username doesn't exist in that chat, hit us up over Slack, and we should be able to help you. So like I said, I'm going to give people like 4 or 5 minutes to do that right now.
So where do you have the credentials for logging into Azure?
Hi. Hey, no.
They're pinned in the Slack channel.
Yeah.
If you scroll up.
Yeah, under the pinned items on the right, you'll see them. Hey, Chris, I did have one question for you. Just I know I'm supposed to use Slack, but I'm ignoring that. You know how when you deploy to Azure, you have the output that you can see as a ARM template. You know, it shows you on the deployments. Like if you showed your screen again,
Yeah.
on the right of the resource says deployments, and it usually shows you what it did. Does Terraform not do that as far as getting that populated? You know,
So
like
we've talked
the
to
deployments
Microsoft
on the
about
right.
Yeah, so we've talked to Microsoft about that, right? About building that language in there. That hasn't happened yet for them to just generate that code to show you what it was.
Okay.
But it's certainly something that we're interested in.
Okay. Yeah, I was just curious on that.
Let's see. Gonna look through this Slack. All right, if anyone's having any problems getting in, like I said, hit us in Slack. I'm going to give it about another 2 minutes, and then I'm going to get started again. If you guys are not on the Slack, you should have got an invite to join that. Please join the Slack because that's where the best place to ask questions and get help as we're going through this. All right, I'm going to keep going. Like I said, if you're having any issues getting in or any of those problems, please use the Slack. The credentials are in there. You should be able to just log into the portal, but if you have any problems, like I said, Sean, Ryan, Kevin, Justin should all be in there, and they all are admins. They can make you a new account, reset your password, whatever they need to do. So let's get back to sharing my screen. Later. And back to slides. So just review what we did here. Understood the Terraform workflow, and we should have got connected to the Azure Portal and launched the Cloud Shell. And hopefully verified the Terraform is available there. So now let's do something interesting with Terraform, because just seeing that's installed is not that cool. So what I'm going to run through now is going to be a whole bunch of commands that we're going to use in the next exercise. And just all good commands to understand and get yourself familiar with Terraform. First, Terraform Help. Also, if you run Terraform with nothing behind it, this will print as well. It shows you all the commands. You can also do, as you create a path, you like Terraform Plan Help, kind of that, to get more information about specific commands. So Terraform init, we saw this earlier. This initializes our workspace. If we do any updates, by the way, where I added a new provider in my Terraform code, you're going to need to run Terraform init again. Terraform plan, again, part of this init plan apply workflow, shows us what we would create without actually going out there and doing it. There should have been an apply slide. Terraform Destroy. This is a very useful command, and one of the big advantages of Terraform is that if we need to, we can clean up everything that we know about. And the cool thing about this is it'll just delete the things that Terraform is managing. So if you have multiple people going into the same Azure account, like we do today, and you run Terraform Destroy, you're not going to destroy other people's work. You're only going to destroy the stuff that you were managing with this one particular Terraform workspace. And it's a quick and easy way to get rid of everything if we need to. Terraform format. This is a great command to use. So Terraform is a very forgiving language, unlike YAML, where if you get your spaces wrong, it'll just die. Terraform will generally accept a lot of things that are really ugly looking. However, there is a right way to write it. We like spaces. We don't like tabs. We want the equal signs to be lined up, and I want that final curly brace to be on its own line. This command will automatically fix your code. And so part of a workflow and like a CI pipeline that people build is often ensuring that any code, any pull request that gets committed passes Terraform format without actually requiring any changes. So that way we have all of it done appropriately. There's also plugins you can get for things like VS Code, which will run in Terraform format every single time you save the file. And that'll just ensure that your code is always formatted appropriately. So Terraform Validate is to ensure that all the code in that Terraform folder is valid. You can also have it applied just against a particular file if you'd like. We also run a validate for against anytime you run like a plan or apply or refresh or most of our other commands. We validate at that time as well. If you want to just check it, you can run validate by itself. This is just a basic syntax check. Right, this doesn't tell you that your code's going to work or that parameter really exists for that piece that you've got there. This just tells you that, hey, the code looks like it's valid syntaxically. Refresh. So again, this is something we actually do automatically before plan or apply. You can disable if you want, but we maintain a state file we're going to talk about later. And what this does is it actually goes out and checks that what's really out there in the cloud provider or whatever you're managing is consistent with what the state file says. The state file usually gets updated after you do an apply, but maybe say one of the VMs got killed through the UI or it just happened to die up in Azure. A refresh will update that information in the state file and will understand, okay, this needs to be updated now because this has changed from what the current reality is. Terraform Output. So if we have, we'll create output later, which is useful information to know that either comes out of a module or your Terraform code. And it will be printed at the end of every apply. But sometimes you want to get back and see that information again. You can always run the output command. You can also pipe that through JSON or ask for a particular output if you only want to get one. Now, this is useful for tying this into a CI workflow or some other automated tooling, and I need to get particular bits of information out of Terraform after it successfully runs and hand that back to another system. Terraform graph. This is a really cool one. So we create what we call as a directed acyclic graph. We'll talk about more later, but that's where we actually model all of the dependencies and the order in which we need to create everything inside of the Terraform environment. We get a few cool upshots of that. One, we're written in Go, so we're multi-threaded, so we'll always be faster than anybody else to actually deploy anything out into the cloud because we're not going to be bottlenecked doing one item at a time, reading top to bottom. We'll go through, understand the order that everything needs to be done in, and then do it as fast as possible, walking down that graph. Part of that, though, it becomes important to understand that the order things happen in, and so graph shows you the order of what that is. And if you pipe that through something like Dot, you can actually get a pretty picture and see, oh, here's all the dependencies of how everything goes. I know at the very bottom, right, I need to have my Azure provider, and then my resource group, then my virtual network, and then the subnet, as well as the public IP. The network interface relies on both of those, and then the virtual machine uses that, and then I can close out. And so now I know, okay, this is the order it will always happen in. If I see that, the virtual machine, for some reason, is relying just on the provider, and then I start getting errors because it really needed the network interface that wasn't done first, I can come back in here and look at why those not have that relationship. There's a bunch of commands we can do on the Terraform state. So I already ran the Terraform show to show me what the state is, but we're going to use a bunch of these here at the end of this so we can see either the full Terraform state with show, or I can list the items that are actually just in the Terraform state, because most of the time your Terraform state gets to be quite large, and I don't want to see everything. So I can list the items that are in there, and then I can do Terraform state show and then a specific resource ID or resource name, and then see information just about that one. The state file here, it's in JSON. You can come in there and open it up and read it yourself as well. I don't recommend it. I recommend using the state commands because they're much easier to actually go through here and read. So let's talk about state to begin with. Terraform as a language is a desired state language. So we don't talk about the iterative steps of what you need to do to get somewhere, like how do I go actually deploy a VM. All we expect you to say is that you want a virtual machine to exist. And then we will figure out if that is the current state or not. And so what the state is that the config is the desired state. The state represents the current state, how it is actually configured today. And then we look at the difference of that. And that's really what the plan is presenting that difference to us. So we understand that this is my desired state, and this is what currently exists. So this is what I have to change in order to get there. Again, the actual commands to do that are obscured from you. You're just looking at the difference between two different states. The apply resolves this and moves us so that we're in the desired state. So here's a cool little quiz here, and something to help people understand what goes on with Terraform. So we look here at a bunch of different scenarios. So if we're going to run a Terraform apply, and here's my desired state, here's my current state in the state file, but here's what actually exists in reality. And remember, the state file is written at the end of an apply. So unless I've run a refresh, in theory, this could somehow become out of sync with reality. So let's see what happens. When I create that Terraform is in my desired state, but it doesn't exist anywhere else. Well, this is a situation where I've just written some Terraform code, but I haven't applied it yet ever. In this instance, I'll actually go out there and create that virtual machine. This next instance, it exists in the configuration, it exists in the state, which means that it used to probably exist in reality, but it doesn't exist in reality currently. This is a situation where something broke, somebody went into the UI and deleted this machine, or for some reason Azure had a hiccup and that machine got deleted. In this circumstance, when we run that apply, we're going to actually refresh the state, find out that it doesn't exist in reality, and we're going to create it. So this next one. Exists in the configuration, exists in the state, exists in reality. We run an apply. We're not actually going to do anything because it's already in our desired state. Again, we compare this to something like poorly written Ansible. What people often have where they'll write a script that's going to go create, say, 5 VMs. And if they run that script again, they're going to get 5 more VMs. We don't do that. We track the items we created before, and I know what those are, so I'm not going to go create a new one. So what about this instance where it exists in the state file and it exists in reality, but it's not in my configuration? This is a really powerful message to think about what Terraform can do for you. And this is an instance here where, say, I had written in my Terraform code that I had 5 virtual machines that were part of a cluster to service my application. And then ultimately I decided what would actually be better than having 5 machines specified by themselves, what I should actually do is create an autoscale group. And so I go delete the code about the virtual machines and I create some code about an autoscale group. In most other provisioning mechanisms, they would forget about those virtual machines that you deleted from your code because you didn't actually tell them to go delete them out in reality. We remember because of the state file that we used to manage this virtual machine. So when you run Terraform apply here, it's going to know, hey, I used to manage this. I don't anymore. I need to clean it up. So it's actually going to delete this virtual machine. Next instance, right, exists in the configuration. There doesn't exist configuration, doesn't exist in the state file, but exists actually in the reality. So this is somewhere where this is created with separate Terraform code, where somebody created it by hand in the UI. Well, Terraform doesn't know about it, and it's not going to touch it. We only touch things that we know about. This next one's an interesting use case situation. It exists in the configuration file, and it exists in reality, but it doesn't exist in the state. This is one that often trips people up about thinking, what would actually happen when I run applying here? In this instance, we actually go and we call, say, recreate, which means we're going to believe that there's something this does not exist because it's not in the state file. And since we track everything by unique IDs, I have no way to associate these 2 items. So we're going to create a new virtual machine, and we're not going to touch this one. For certain resources where that's okay, right? I can have multiple resources with the same name. That'll be just fine. I'll have 2 of these. Some resources need to be globally unique. And in those instances, I'll end up running into an error because Azure will say, hey, you can't create something with the same name. And then finally, exists in the state file, doesn't exist in the configuration or reality. Well, we're just going to update the state by removing it from the state file. All right, so let's actually go deploy something with Terraform. So what we want to do here is have everyone go into the Cloud CLI and start writing some Terraform code. Now, we want to create a resource group, and I would like to explicitly state that the Azure RM provider be used. So we need that syntax of the provider as well. You don't just use the fact that putting the resource group in there will do it. And pay attention to this here because there's a whole bunch of you doing this. If you guys just start all naming this test, you're likely to run into each other. So we can use that same sort of syntax I showed in the demo. You can use a random ID as part of your resources to pass that in. This is the format you'll want to put in the name parameter. It's random ID.projectname.hex. Put this in there and then maybe some other thing, for say resource group or something else. But this is how you're going to pass that information back and forth. So let's take another 5 minutes and go through this exercise. Like I said, if you have questions as we're doing this, please put them in the Slack.
So Slack, I'm not getting any response, so I just ping a couple of messages, but I don't see any response there.
Where are you in the training?
In the Slack channel? Yeah, are you posting to Slack or where are you posting?
Let me share my screen again. So this is called the Capgemini Hashi Slack, and it's a training channel is what everybody is in. So hopefully this is where you're
Yeah, if we haven't answered a question, just respond in a thread and we'll make sure we're on it.
What is the name? It says training, right? Just training.
Correct. Yeah, the Slack channel training.
Got to make sure you're in the correct organization. So we sent out, this is the Capgemini Hashi training organization. We sent out invites to everyone today. If you're not in here, you'll want to join this.
Yeah, got it. Yeah, just we need to search on the training. So I just used the app, so it went into chatbot kind of a thing. Yeah.
Yeah.
Sorry about that.
And just give people another couple minutes here. I'm going to double check and see how many of these things have been created. Hopefully we should start seeing some resource groups pop in. Yeah, I'm seeing a few of them already come in here. Cool. I'll let's get a few more before we keep going.
Chris, while we're waiting, is there a best practice you have for identifying resources that were terraformed in the portal, or like tags or something, or any other way to tell?
I recommend people put tags on things when they create it. I think there's in the actual audit logs, we can come through here and look at a resource. It's created. There's some. I know Microsoft is able to tell based on every time we do a call out to the API, we attach a bit of information to what we're doing to tell it that we're provisioning with Terraform. And I don't know if you guys can see that as well. I'm just looking at.
Yeah, I just see in the logs like event initiated by, and I'm using my own environment by the way, but just by myself, like it's not clear that it was done through Terraform. Yeah. So.
Yeah, I'm just trying to see if I like. So I know Microsoft has a way to determine it. I'm just wondering if that's something they exposed to you guys or not.
It is actually exposed in the logs, but you have to have logging on and polling for that, but you can capture it.
Oh, that's awesome. Thank you.
So Dave, do you mean the logs turn logging on for what though? Like additional logging for like everything?
I did it through Log Analyzer, Siku. So I just picked it up through Log Analyzer, but and then write it to a blob basically, and then parse the blob.
Okay, so you got to get it from the blob. So not the standard activity log location.
Yeah, you have to do some. You can't use the cloud native. I know what you're talking about, like in the GUI, right? But if you have Log Analytics on and you're polling for it, you can filter it out and get the. I think I'm pretty sure it was JSON.
Okay, yeah, I know what you're talking about.
Yep.
Makes sense.
Great. We have one more minute, and then we're going to get started again. So you guys can always continue doing this in the background as we go through. And like I said, all of the slides and workshops are there if you've taken that link. So you don't need to necessarily be waiting on me to be showing you the exact exercise. It's all right there. All right. Let's go back to the training. Here. So there's a resource group. The next challenge, hopefully you guys are in this managing state file. So if you've not started this one, let's do this one as well. I'll give you guys a minute, and I'm going to actually show you all of this as well. Let's just go through here and show this. Right, yeah, cool. So I'm going to do Terraform show. It shows me these are the resources that I've got created. See, something useful here is this ID, which is what we'll need to do an import later. So I'm going to do Terraform state list, and I can see here's the resources I have to manage. If I wanted to, Terraform state show and do this one resource. I can do now Terraform state remove and put that resource name. And now if I do no, you see it's no longer my state. Ran a plan. Here Terraform would see, hey, this is no longer the state. I should go create this. This should have a collision with the existing one. There's been a bug lately, and I don't know if it's fixed, but it'll just silently work. But that's something that's supposed to be fixed in the current provider. But I want to do Terraform Import. And we want to say this. So I put what I want, the unique name I want to import that matches the Terraform. Then the ID that's actually there in Azure. And I can import it. Now we see that I've got it associated again. If I run a Terraform plan, it should no longer want to recreate it. It should just believe that it's set up appropriately. Import's particularly useful if you guys, I find this on Azure. We get this all the time. On AWS, we often have this with VPCs. Some of the stuff got created by hand or something at the very beginning, and now we're deploying everything into it. But we want to manage this like it was created with Terraform in the first place. Import's a great way to do that. So you can come in here and you can understand, all right, this is the stuff that I need to, that I've already created, that I want to act like it's there. Write the Terraform code that matches it, and then do imports. One tool, this tool isn't perfect, but it's something that's created by Microsoft CSA called AZ2TF, and this will help create some of that Terraform code based on stuff that already exists out in Azure, and then do the association based on it. Look, you wrote a newer version. But this will probably only get you 80% of the way. You're still going to have to fix stuff manually. So I want to just look at this as a holy grail. You're going to get perfect Terraform code out of it. But if you do have to migrate stuff that was created with ARM templates or this created by hand and you want to move it to Terraform, and there's a lot of it, this is definitely something worth looking into.
Hey, Chris, real quick on that. There was a question in Slack on it. Sonny and I both have been working with this too. That's the piece, right, that's under development and on roadmap to kind of do the final import and write the Terraform code from an import command. Is that what's on roadmap? Because I'm pretty sure you hit it right there is what we were looking for.
So there is internally we write things called PRDs to describe the product we want to create. That one was written like 2 years ago by Mitchell, one of our founders. I do not know when it's going to ever get done. We have, from the sales perspective, we've been pushing, and there's been some tools that have been created by another one of our partners around AWS to do something similar. But I don't know where on the roadmap that's going to actually fall for us baking that tool in natively. The biggest issue is it's one of these problems where it's really easy to solve this from an 80% perspective. It's rather difficult to solve it at 90% perspective, incredibly hard at 95%, and impossible to do 100%. And it's hard for us to like ship a product that is probably only going to 90% work and then tell you to go use it. So that's one of the reasons I don't think it's made any immediate roadmap. But it is something that we're having conversations about internally. So I wouldn't be surprised if something gets created, but I've got no timeline or promises around that.
Thanks. Appreciate the clarity on that. Awesome.
Of course. Cool. So let's do some more Azure and Terraform. All right. Make sure I'm still sharing my screen. All right, so we created our first Terraform resource, and we managed the state file. So chapter 3, expressions, variables, and outputs. So expressions. These are powerful tools to reference data from other locations, perform functions, iterate. If you guys are familiar with Terraform, so Terraform recently released 0.12. That included updates for what we call the HashiCorp configuration language to HCL2. And prior to the HCL, in HCL1, there's a separate language called the HashiCorp interpolation language. Technically, we don't do any interpolation anymore. I just haven't got that out of my lexicon. So if you look at here in the prior version of Terraform, it was this $ curly brace. It's how we called from the HashiCorp configuration language to call out to HashiCorp interpolation language. And then everything cool had to happen inside of that $ curly brace. There are some limitations to what we could do with that, and we wanted to get true loops and things like that we just couldn't do with the interpolation language. And so 0.12, HashiCorp configuration language 2, has all of this natively built in. So now we call these things expressions. And so we no longer need to put them in the $ curly brace. If we're using this sort of dot syntax that I've got here, so like var.name, we understand that you're referencing a variable, and we'll go look up the value of that variable. If you're sticking inside of a string, like we did with naming this project here before, you're going to want to still use that $ curly brace format because you're going to have other parts of that string. If it's just this by itself, you can drop these quotes, drop all of that, and just dump this value. And if it's a string, we'll understand it's a string. And by the way, something I'm not going to cover extensively here, but there is a command, if you see in Terraform, called 0.12 upgrade. So if you've written Terraform code in the past, and you've written for a prior version, and you want to use it with 0.12, recommend using this. We automatically upgrade nearly everything. So we're trying to make this process of moving from the prior version to the current one as simple as possible. And this is really the big tool around that. We will automatically do those upgrades. You can then commit the updated files back to your version control repository. We'll also create another file called versions.tf that will tell you to say use a Terraform version greater than 12 going forward for that code. But definitely look into this if you've already written some Terraform code in the past. Cool. So count. This existed in prior versions as well, although actually you can no longer name a variable count, so I have to change this example because we now have that as a keyword. But what you're doing here is we can create multiple resources that are identical as long as you go in here and you tell us the number that you'd like us to create. And what we do is in the name that we have internally, we'll put a number in there, starting at 0, then 1, then 2, then 3. And then if you want to update information inside of this to be different, you can use this reference to count.index. And one of the cool things here is you can actually see I can tie some of these pieces together here. So where I've got, hey, I'm creating all of these network interfaces, and they're going to be 0, 1, 2, 3, 4, right? Or in this instance, 0 and 1. And then I need to reference them over here. So I need virtual machine 0 will get network interface 0 because it's matching this count ID over here to the network interface IDs. We also have the concept of loops now. So we can do dynamic blocks inside of some code. So I could say here, well, I've created a definition variable of subnets that say has 3 subnets defined. For whatever those are defined, I'm going to create a dynamic subnet block inside of my virtual network. So this allows us to dynamically generate code, to have loops, makes things much easier than before where these pieces inside of the code will iterate the entire resource. I couldn't iterate just subsets in there. We've got more cool stuff that's coming with 0 to 12. This rewrite really allowed us to make this language a lot more powerful. So these sort of dynamic for concepts that are for X and Y sort of concepts that people are used to in other configuration languages and other scripting languages, we can start doing these things in Terraform now too. We can do conditionals. So say I've got a variable about setting this VM size. Set it to small. I can use this. And if you've not set it, then we'll use the other one. Makes your code much more reusable. It was a little quirky to do something in 0.11 and earlier. If I wanted to just have that resource or not have that resource as a conditional, I'd have to do that around having a count at 0 or a count at 1. But we can now do that in a better way where I can actually create a conditional here that says, hey, if this variable is defined, then create this resource, and if not, then don't, kind of thing. We can even do math. So if you're one of those people that hate when all of the machines that get dynamically created start with 0, you can just add 1, and we'll add 1 to it. We have a ton of built-in functions as well. This is just a few of them as examples. So we can say here, I'm going to combine 2 variables here in one list, or I'm going to pick an element out of a list here. This is very helpful where I need to come in here and understand, all right, here's my list of, say, all these subnets or other bits of information. I need to get the 3rd or the 4th one out of that. I can do that. And then format, right? If I need to say, in this instance, I want to name my web servers and I want to have a leading 0. So they're all 2-digit numbers. I can do that as well. So the next several exercises. So that's Chapter 3, Exercise 1, 2 here. What we're going to do is actually set up the Azure networking. Pay attention to this hint here. So standalone subnet resource. You'll actually see if you go to virtual machine here, you could define subnets inside of the virtual network resource. We don't want to do that because we're going to actually use a count in the next here to actually create more than one subnet. So I highly recommend going and looking, this other example here. All of the Terraform documentation always has great examples of working Terraform code on how to do it here. And something I often recommend is go for the more advanced code as far as determining what you want to do. So for this instance, this code here for the network interface does almost everything that you're required to do in this task. The only thing you have to add is a public IP. So this is probably a great template to start with, but I want to make sure we link you to all of the documentation here. But yeah, like I said, sometimes it's easier to start with the advanced one and get the prerequisite code than it is to look at the examples on the earlier stuff, because when they do that, they tend to try to show more complicated examples for the earlier stuff. Cool. So let's take another, say, let's call it 7 minutes until what's 9:25 West Coast time. and go through this.
Okay. And just a quick question for you, Chris. Are you planning to always review the solutions to these for people?
I will, yeah.
Yeah. Okay. Just want to make sure. Want to make sure we get those recorded. Thanks.
Yep. And I can make those solutions available as well for people who need them.
Like in a Git repo or something?
Yeah, they're actually in this Git repo.
Oh, they are? Okay.
So, yeah.
Cool.
They're easy to find if you want to go looking for them. All right.
Hey, Chris,
Let's
one
get-
quick question, or I guess you're going to start, but a really quick one. I was curious if something was set manually. You mentioned those examples of at the resource level, but if like a setting was set manually within a resource, is there any way to import that or ignore it, like don't override it kind of thing at the setting level?
So we will only pay attention to the items you tell us to pay attention to. So if you look at, say, the documentation, right? So let's say Azure virtual machine, your virtual network. In the documentation, see there's a bunch of things that are optional. If you don't specify the optional items here, and those were set manually, we will just ignore whatever those settings are. For the required items, you have to set them, and we'll care about what they are. But most of the time, we require as few things as possible. The things that are required are generally pretty important for that resource to even exist.
Okay, so if it's optional, you shouldn't be overriding it. Because maybe we can take this offline, but there was an example with some flow logs that were turned on manually and then get turned off, So anyway, it's...
Yeah, if it's an optional setting, you just don't include that parameter, and then we'll ignore it when you do the import. But that's one of the value things. Whenever you do an import, I always say do the import and then do a plan, because at the end of that, it shouldn't want to do anything. If it does want to do something, that means there's something about your desired state in your code that doesn't match what's out there, and so you want to get that updated. But yeah, it's going to be on a resource-by-resource basis.
Okay.
Cool. So let's dive back into it. So hopefully you guys have these virtual network resources created and this count. I'm sharing my screen. Cool. So let's talk now about variables. Again, makes Terraform code reusable is that you can use the same code and do it slightly different. Particularly, we're thinking about sort of DevOps, CI/CD mentalities, right? We want to be able to put the Terraform code itself, in addition to everything else, through a CI pipeline, where I'm pushing it between, dev, staging, production kind of ideas. And that means that they're going to have different sort of variables that are going to be part of that. I'm going to have slightly different things I want to tune, right? I might be using different keys. I might want to build it at a slightly different size, a bunch of different things I want to do. That's where variables are really powerful. We also use these in modules we'll talk about later. So we see we define variables here. We define whatever the variable we want. We can put a type definition on the variable. This is very helpful for error handling. Right? The individual resource that you would assign that to may not give a good error if you pass a string when it expects you to pass a list, or you pass a map instead of a list kind of thing. But if you put in this type definition as part of your variable, which is always best practice if you can, you're going to end up with an error that very clearly says you can't pass in that type of data to this variable. You can also pass in defaults. So again, as we're trying to make our code reusable, I try to put defaults everywhere that I can, and then hopefully you just override those defaults so people can specify the minimum number of things. And then we can see here, as we saw before in the example for the expressions, just var.name of the variable to reference it. So where do variables get their values? So besides the default, there's numerous other ways you can pass it in. You can do it at the command line when you run a plan and apply and do a -var. You can also create a Terraform TFRs file. And you can either pass in the var file at the command line, or if you call it exactly terraform.tfrs and it's in that folder, we'll automatically pick it up to populate those variables. And then you can pass it in as environmental variables. Depending on your workflow, some of these may be more useful than others. I see oftentimes when people are using things like Jenkins and CI pipelines, they're either passing it in as -var at the command line, or they're using environmental variables. They've got multiple steps and they pass information back and forth and don't get it directly. For people that are running it locally, this terraform.tfrs is a fantastic way to do this. Don't commit this to version control. You're going to hate yourself if you do that. One hint, by the way, for you people that are going to be putting this all in version control, git ignores are amazing, And when you actually create a new repository in, say, GitHub, they give you an option for git ignore files. Terraform is one of those. And I highly recommend always having a git ignore in there. It's going to keep out these TFRs, which probably have secrets we don't want to have in there. It's also going to keep out these state files. State files often have secrets in them. If you're generating usernames and passwords and things like that, they're going to end up in here. So you want to keep your state files out of version control. Highly recommend you guys always have a git ignore. Cool. Outputs. Outputs gets information back out that's useful. You know, we can always go look at the state file and do what we were doing before, where I go say, show me all of the things that are in the state file. Now show me this particular resource. Great. That's kind of a pain if you want to get information. You want to make your code easier to use, or you've got a DNS name or a public IP that is actually creating. Write an output. Make everyone's life easier. Locals are a great place to store information that you don't necessarily want to have as a variable, or data where somewhere you're going to reuse something multiple times, but you don't want, and you need to do some munging of that data, and so you don't want to have those functions on every single place you're going to reuse it. A local is a great way to use that. And we'll actually use a local here in the coming challenge. So a couple more challenges here: variables, outputs, and locals. What I want you guys to do here: create a variables.tf file. So we've been operating on our main.tf before. Let's create a separate variables.tf. In the next section, I'm going to talk about organizing your Terraform code and why you would do that. But let's create variables for the location, tags, and the vault binary URL, and set these as defaults. And then you're going to want to update the main.tf to use this location variable instead of where we had hard-coded it in before. And then outputs, we want to make an output here. All this output is doing is actually giving us a useful command. By the way, as you'll see, we mentioned vault a bunch in some of these exercises. What we're actually doing in Terraform today is we're standing up HashiCorp Vault. If we were going to do the second part of this workshop, which we're not doing today, we actually do all of the prerequisites to do a Vault workshop as part of the Terraform workshop. So even though there's a bunch of Vault stuff here, we're not actually going to use Vault. But that's why it says it there, is because we're doing these prerequisites to stand up an environment, and the application we happen to be standing up is Vault. That's all going to be on Terraform today. So this is, create this as an output, and you can see here we're referencing that variable. And then a local, we want to create a local for tags. No, this is to the old one. So I want to, what I'd like to do is merge the project name that we've created as that random ID, if we created that, with that variable we created for tags. So we're going to have one set of tags that combines both of those. So let's take another, let's call it 10 minutes to go through. There's a few things in here. And I will go back to the chat and answer questions. for people that are already done, you're welcome to move on to the next exercises and get ahead if you'd like. There's a bunch on here, but it's all in that slide deck. All right, let's get going again. If you guys do need any assistance, again, please go to the chat. If I'm going too fast for people, let me know, and I can spend more time as well. So let's go back to slides. Forgot I did not actually go through the last one and show you guys how it's all working. So I'll do that for both of these. So here's the updated for the networking. So we already had the project ID and the resource group. Now the networking resources. So you might create my virtual network. I create a subnet with a count of 3. And you can see here I've used the count.index and some math to iterate the CIDR for the different subnets. And then I create a public IP, and then I tied together all with this network interface. And you see where I'm actually passing in the public ID here, as well as the subnet. So you can do form state list. You can see I've already got the Azure group and the random ID created because I did that before. Now I can do a Terraform plan. And we can see we want to create 6 additional resources. One thing I haven't mentioned before, you'll see this every time you run a Terraform plan. There's a -out flag. So if you're using a CI pipeline, you probably want to be using this. What this means is when I run Terraform apply, notice that it does another plan, and then it asks me if I want to actually apply that plan. Well, I could do a Terraform plan-out, write a plan file, and then pass that into Terraform apply. And what that would do is actually allow me to ensure that I'm going to use that exact plan. The benefit is we have multiple people collaborating on one set of Terraform code. It's potentially possible that somebody could have changed the code after you ran a plan and before you do an apply. And if you had somebody go through there and like validate, hey, this plan is exactly what I want, and then they don't look at the one that gets generated on the apply, potentially something unexpected could happen. So by doing that plan out, you ensure that the only changes we made are the ones that were in that plan file. So we got through here and we created all these pieces. So now we have those resources. Cool. All created. And you can see I've got 0, 1, and 2 for my subnets. Now, you can actually see, so what I've done is I've added in a variables and an outputs. So let's look at what those are. So this is the exercise we're doing here. I've got a variable for location, set the ECUS. I've got tags. I've set this as being a map of strings. Cool thing for this typing is I can actually say, hey, it's a map or a list, but the data inside of it needs to also be this kind of list. And then I've set the default, and I've set this binary URL, the string. And then we can see here in the main, I've updated my resource group to use the variable for location. So now this is easier to override if I want to move this. And then I've also created this local. You can see where I'm using a function, and I'm actually merging that variable tags with my project name that gets created. So this way, when I actually create these tags, and I can put them here on the resource group, most of the other resources in most cloud providers, honestly, all support the tags as well. So it's common practice that people will go through here and add tags on every single resource. I didn't ask you guys to do that here because it's a bunch of repetitive stuff. You should get the point, hopefully. But this is a local is a great way to do something like this, where tags, where I want to merge a bunch of stuff together, and then I want to tag everything with the same tags on them. So this is a good sort of best practice. And then I created finally an output for this information. Now if I do a plan again, we can see that what I want to do is actually just add the tags, because even though I added these variables and the outputs, the variables didn't change what the location was. The only new change that I added was adding these tags. Cool thing you'll notice here too, you can do a change. So we understand that certain things allow me to just change it without destroying it, and other things require me to destroy it. Right? If I update the size of a VM or the image that a VM is using, I can't make that change live. I have to destroy it and recreate it. But a lot of things, like adding tags, I can change to an existing resource without destroying it. Terraform's smart enough to know the difference. So we do apply. Hit yes. And we updated that resource. And now you can see also, I now have an output out of here. So before we just stopped at apply complete, because I added outputs, I get those at the end. If I needed to get back to those, like I said, I did a clear, I lost them, I always run Terraform Output and get that information back. I could also ask for that in, I'm not sure that's the right format. Yeah, so ask for it in JSON, and I can get that information. So if I want to do pipe that through like JQ and say dot, I think that's right. Well, I could pipe it through if I actually knew how to write JQ appropriately and get just that output. So like I said, if I'm piping this to another system where I need just to value that output, we can do that pretty easily using JSON. All right, let's keep going through the slides. Cool. This is not the one I was using today. Cool. So chapter 3, we learned variables, outputs, and locals, and then we updated our Terraform code to use those. So let's talk about organizing our code. So what we have now is that variables, outputs, and main.tf, right? And that's a very, very common workflow you're going to see all over the place. It is, however, not required. We don't actually care about the names of any of your Terraform files as long as they end in .tf and they're in that folder, not subfolders, but in that directory. We combine all of them together and treat them like they're one file. So you could name it garblygook.tf and put literally everything in there, and we would operate just the same. This is a convenient way to set stuff up for just to have a common design practice. Like I said, you'll see this all the time. I always recommend that people start with here, but sometimes, say, the main.tf just gets too long, and it makes more sense to break out sections of that into their own TF folders or TF files. That's totally fine. And you'll see this with modules later. Sometimes it makes sense to actually break the code entirely out and put it into a module to just simplify what you're doing. You want to make sure that this stuff is readable. And if I have thousands of lines of Terraform code, it's not going to be very simple for people to go in there and understand what's going on. So comments, there's several different ways you can do comments. I prefer this way. This is technically allowed too. And you can also do block comments like this. Whatever you guys want to do, make sure you put comments. Put information that allows people to actually go in there and understand the code, make it usable. I highly always recommend doing that. At the end of the day, it's just going to help somebody else be able to understand why you did what you did and what's going on. It's also good for organizing. As you notice in the examples that I've got from these solutions, I've been putting in things that highlight the section of what I'm managing. So if somebody's looking through it, they can expect to say find all the networking stuff in one location. Data sources. These are really powerful, and you will use these a lot. So sometimes there's things that I want to have, some data I want to have that I can use for resources I don't necessarily want to manage. Sometimes I can't manage them. Other times I just simply don't want to. So if you can think about a resource group, right? Or what's more common, right, is the virtual networks. Oftentimes businesses separate different units, different BUs that control different pieces of their cloud out there. So you may not be that the organization has full access to manage and say create its own networking. Somebody unmuted. I don't know, is there a question or is that?
I'll find it.
Cool, thank you. Cool, so we need to go in there and find information about, say, that other network that was created that I need to use for my application now, but I don't want to actually go manage it like it's a resource. So doing an import isn't the solution that I want. We can use data sources to find that information. And there's a bunch of different data sources that are out there. There's two examples here. One, I'm doing a search for an image. So you think about this, again, so I'm trying to make reusable code. Oftentimes I want to have, say, the latest of a certain image. This is very common on AWS with AMIs because they're constantly changing. You don't want to have a variable input for AMI because it's going to change on you, and it's going to be really annoying. So you use a data source to search for the correct one that you want and update that appropriately. We also can look at these Terraform state files for other Terraform workspaces. So where I may have a different team that manages the networking, I can see the state file. Even if I can't manage those resources, I can pull out all the information that's in there and use it just like I would use it if I was managing all in the same code. Another common thing that we use is state files for data files, template files. So that's something what we're going to do in this next challenge. If I want to create, say, what we're going to do here, I want to create a user data script for the VM that we're ultimately we're going to create, but I need to pass in some dynamic content. I can use a data source to do that. So here what we're going to do, we're going to create two of these data sources. First, I want you guys to create a data source for Azure RM client config. Pretty much anytime you're in Azure, you're going to end up needing to use this data source. This tells information like my subscription, my tenant, if I'm using a service principal, what the service principal information is. All of that gets loaded from that data source. Very useful. And then we're going to create a template file. So I've already created the file for you. You can come here and just download the code for this. Put this in your directory. And you can actually see here in this file, I've got some things where I'm going, here is the information I really care about. I'm passing in a variable, which is my vault URL. We want to make sure we can pass that information in to the template file. So let's use that to add that to the code. This one shouldn't take too long, so I'm going to give you guys about 10 minutes, and then I'm going to go through and do it. Sorry, I'm going to give you about 5 minutes until 10, and then I'm going to go through and do it. And yeah, that's the only exercise before. All right, let's walk through this one, and then we're going to go through 5, and then I'm going to take a longer break if people need to step away during the 5, so it shouldn't take us very long to go through chapter 5, and then we can take a break. So let's look at the code that I added. So I added this script. We already looked at that, and when I looked at the raw data, I'm going to look at the main now. And let's open this anyways. The other one crashed. And we can see I've got my template file. And we can see I'm pulling in this file locally, and I'm passing in the variables. And like I said, within the template files, we can define those variables. The variables have the same $ curly brace. That happens to be something that Bash uses. So you'll notice if you read that setup vault.tpl, there's a bunch of $$ curly brace. That tells Terraform to ignore those and not try to populate that information, because that's ultimately going to become variables for Bash. And then it's just a $ curly brace are the ones that we're looking at to replace. I've created this here. If you happen to run a Terraform plan, Terraform plan, we should get an error because we added a new type of resource, which is something we didn't have in here before. We need this for the template, provider template. So I can run another Terraform init, and this will pull in that new provider. I should be able to run a Terraform plan. And because I just created a data source, probably won't want to do anything. Now, apparently, the resource group got destroyed. All right, well, that's interesting. It shouldn't want to do that, but let's go recreate it anyways. Destroy. Why is it will be destroyed? That's interesting. I wonder if I tainted it or something. Interesting. Well, that run, and it should create the data source, and then we'll actually see that in the state file as well. We'll have both the data sources get loaded in the state file. We'll see the original template and the rendered template as well. So if I wanted to pull out that rendered template and use it again, it's in the state file. So let that run, and we'll go through chapter 5. So modules, internals, and backends. Talk about how we use modules and how we make this code reusable and pass variables back and forth. So cool thing is you've already written a module. There is no special thing you have to do to make your Terraform code a module. Literally any valid Terraform code can be used as a module. What makes it really useful is when I have variables and inputs that allow me to pass in useful information. One of the things to note is that variables are scoped within that module. So there's no inheritance. I don't automatically have the ability from in a module to look at information or variables from the root code it was called at. If you want to pass information into a module, you need to create a variable and explicitly pass that information in. If you want information out of it, you create an output in that module, and then you can call it out. There's a couple special parameters here. So source and version that we have for modules. There's a bunch of different sources for where it could be storing my modules. What we're going to do today is going to be a local subfolder. That's a relatively common practice if we're just trying to simplify our code. But if we want to actually reuse this in multiple different locations for other code, it's not the best place to put it because I should be putting it somewhere that I can reach and I can manage in one lifecycle. And that could be something like a Git repository. It could be an HTTP URL, but it also could be a module registry. We have the public module registry. I highly recommend you guys go out there and take a look at this. You can search by provider. There's a ton of Azure ones out there. There's a ton of other modules. This is code that's designed to be generic that you can just go out there and use. So you think about, hey, every single time I set up my networking, well, I set it up with a virtual network and 3 subnets, right? And I could write that same code over and over and over, or somebody's actually literally already written it, and you can take their module and take advantage of it. The nice thing about the registries, as you see here, is it supports versioning. So while I can, with a Git repository, I can specify a tag and make sure I hit a specific tag. With the registries, I can say, give me everything that's greater than 1.1 and less than 1.3. So people will be able to add in bug fixes, and I would get those without having the problem that I need to update this thing every single time. But I could also ensure that I don't end up going to, say, too new or too old of a version. We also have a private module registry. So we'll talk about this a bit later, but if you're using Terraform Enterprise, like I've gone and say, what's the best way to deploy a Tomcat server in our organization? Well, we can write a module for that. And it's not something that's so generic that it makes sense to publish on the public registry. It's a little more specific to the organization, but it is something that's going to be reused a bunch across different BUs. Put it in the registry. People can reference it and treat it just like they would if they're using the public registry. So Terraform Internals. You guys might have noticed that when we run a Terraform init, we actually make a folder called .terraform, and that's where we load in all of the prerequisites. So any module you reference gets loaded in here. Any providers you reference get loaded into the plugins. The great thing about this is that means I could have 2 sets of Terraform code running up from the same machine in folders right next to each other with conflicting dependencies, and that's totally fine. Unlike, say, Puppet, where the whole Puppet server has to have a certain version of modules, certain version of underlying code that's there. With Terraform, we don't care. We pull in all of our dependencies to that folder. And you can also, if you want, because it's done with Terraform init, you can nuke this folder and run another Terraform init, and we'll bring it back. We don't keep a lot of special stuff in here. It's just the version of things that we downloaded in the past. We don't always update the items in here, so we don't necessarily want to change if the provider updated a rev or the module updated a rev. We may not update it, so you use a command that you can pull that back down from Terraform and have it update, or you can just nuke the whole thing around Terraform init and we'll pull the latest. Unless you specify a version, then we'll pull that version. Generally keep this out of version control too. It's just not necessary. So backends. We've talked a lot about the state file, right? State files have a lot of important data on what I'm doing. They allow me to do this to-do management. But right now, everything we've been running has been on the local backend. We've got terraform.tf state that's running, that's right there on our system. Well, if I lose that, which actually already happened to me because my Azure timed out over here, we just lose the ability to manage our system, all of these items. I could try to recreate it by doing an import, but it's a huge pain. So we really want to keep these things somewhere safe. And that's going to be a backend. So I recommend, here's an example of where I could put in an Azure storage account. We support a ton of different places to put it on other cloud providers. I put in AWS, S3 or DynamoDB. I could use Console. I could use Artifactory. Terraform Enterprise and Terraform Cloud, which we'll talk about later, have an option for that. There's a ton of places to put it. Please, please, please put your state file somewhere safe. And of course, the other advantage you get out of not only having it safe, but for systems that support locking, this is important for collaboration because Terraform will not let me run, it creates a lock if it can on that state file so that I don't have 2 people running a Terraform apply at the same time that could potentially cause issues. Putting in the back end, super important. So next exercises, we're going to create a module. So we're going to move all of that networking stuff that we created before into a module. And then we're going to define variables and outputs to pass information back and forth, right? So the input that we're going to need, that variable is going to be project name. The outputs we're going to need are going to be network interface ID and public IP, the IP address, because we're going to use those in a later exercise. So write those variables and the outputs, move all of that code in main.tf, and then write a module code in that root module that says calling for that networking module we just created. What you'll notice when you do this, by the way, is that if you run the Terraform plan and apply after this, it's going to want to actually destroy and recreate your networking. In this instance, that's fine. You can let it do it. But the reason it's doing that is because the unique name of this information, it's changed in terms of Terraform's mind. It's no longer, as far as it can tell, you deleted having that networking at all, and then you separately created new networking. We could do an import once we've done that move, and to import those items into the new location if we wanted to, and then use Terraform state removed to remove it from the old location. But in this instance, that's more work than we need. Just let destroy and recreate. And then next, we want to create a virtual machine. So this is where we're starting to tie everything that we're doing together. So we've already created all the networking. We have the public IP. We have that template file. We're ready to deploy Vault and get Vault up and running. Release a machine that's Vault standing on top of. Here's some hints. Use the A2V2. That'll become important later. It's also nice to get the managed service identity. If you guys are not familiar with this, this is super convenient. This allows the VMs to have a system-assigned identity that we can then validate later. So if we were going to do the Vault exercise, this is really helpful that I can validate the machine as who the machine says it is. If you happen to be using a Bastion host to run Terraform code, you can also use this machine managed identity to give access to that machine to manage Azure resources. So you can skip all of this, what we were talking about at the beginning, where you have to say, create a service principal and put those as an export or do AZ login on that Bastion host. I could have the identity of the machine actually have the permissions to create stuff. So it was much more secure than having credentials that somebody logs into that could potentially compromise. So create the virtual machine, and then next I'm going to show creating some non-virtual machine resources. So we want to create a MySQL server. We're going to need to create a password for that as well. So I suggest using random ID to create passwords. I do this all the time. That's actually how I created all of your usernames and passwords for this exercise today, is with Terraform code. Random ID is a convenient way to do that. There's also random string and random pet. What we actually did today was a combination of random pet and random string for your passwords. Create this MySQL server. And then finally, let's add some useful outputs. So we're going to show a few more things that we want to see. One here, let's get that public IP that's coming back from the networking. Give me the FQDN of the server, the SQL login information. Show me the subscription ID. So that comes back from that data source that we created earlier. I want to know the resource group name, the name of the virtual machine, and then this is just a convenient bit of information so that you know. If you've got managed service identity and you want to get the token, this is the command to curl the local host and get the token. I just like to stick this in here because when I said, for people that move on and do the Vault exercise, you're going to need this command, so might as well just stick it in the code and make life easier. So I believe, yeah, these 4 exercises, I'm going to give you guys, let's call it 20 minutes for all of this, and like take a break too, because there's a bunch in here. So let's come back at, let's call it 25. Let's come back at 10, and yeah, no, let's do 10:45. Or no, 10:35. So that's 21 minutes. So 10:35, I will get going again. Take a bio break if you need, and go through these exercises 1, 2, 3, and 4 when you have a chance. If you have any questions, again, I'll be sitting here on Slack along with my teammates.
Hey, Chris, I'm going to display a timer so people can kind of tell when we're
Awesome.
coming back.
Thank you.
All right, Chris, whenever you're ready, timer's done.
Great. Let me answer one question in the chat. I'll get right there. Let's get going again. And let's go back to here. I've updated this with a new module now. So if we look at my modules, I have a networking module. See, I have inputs for research group name, location, project name. You'll notice here when we're doing this for a module, you very rarely, like we're much less often to put defaults here, because usually there's information made back and forth. So modules don't often have defaults. We can still do it where it makes sense. And my main, this is a copy paste from the code that I had before. The difference is that, well, previously I was referencing the exact, say, like the hex off the project name. Now I'm using the variable inputs here that I've replaced this with. And then my outputs, same deal. So here's the two outputs, information I know I need to use elsewhere. Back at our main. All right, so we can see now where I used to have a bunch of networking stuff. I now have a networking module, and I'm just passing in. I've got the source as a subfolder, resource group name, location, project name. I'm passing it in. And then we created the virtual machine and the MySQL database here. And so we can see I'm allowing creative firewall rules to allow that public IP to have access. Got it from all two, but this is always a better practice to lock that down. I'm assigning to that create the virtual machine extension, and then there's the virtual machine. You can see I'm passing in that custom data that I created. I've got a really horrible username and password on it. And I'm passing in the network interface that's coming out of that module as well. And then I created all of those outputs that we had on here. Now, do an apply. And let's see if this does it. So it's got 6 to destroy because I moved this, and we'll see if it yells at me. Looks like we're having some issues. Some people ran into his problems because the network interface is being used, the subnet's being used by the network interface. Mm-hmm. And one thing, by the way, there's a setting for certain things called create before destroy. So sometimes you've got certain instances where it may make sense that I want to create the new one before I destroy the old one, just to have more limited downtime. Again, as we're having a conversation chat about like blue-green workflows, well, people do sometimes use Terraform for blue-green workflows. It's really not what the tool's designed for. And, Armand and Mitchell, our founders, will tell you that. But if you're running the Terraform code multiple times a day because there's changes happening to it, and this is not just development, this is you always have changes occurring, the Terraform needs to run, they're probably doing it wrong. And a lot of these blue-green workflows or canaries are things that a scheduler would better handle. We've got another tool called Nomad. Like Kubernetes, it can manage containers, but it can also manage raw execs, Tomcat, Java, and VMs, and manage it as well, and do the sort of blue-green workflows that we really want to be thinking about if we're doing this kind of work. So this is going to take forever, so I'm not going to wait for it to get done, but we're going to let it go in the background, and it should stand up the rest of our stuff. And now we are going to talk about Terraform Enterprise. So everything we've done up so far has been for Terraform open source. But we wanted to do Terraform Enterprise now to show you guys the value of why your customers should want to move up to Terraform Enterprise and what they'll get out of that. So before I get into that, I should put this slide in here. One of the things we do that I really like as a company philosophically, and this is true of all of our products, the open source for us should always solve the technical problem. What I mean by that is, especially in the world of Terraform, right? If you're looking at Terraform versus ARM templates, I don't want you to choose to go to ARM templates because Terraform open source doesn't do something because we made that an enterprise feature, and ARM templates does. We want to ensure that the de facto solution that everyone is using for cloud provisioning should be Terraform. The things that we build Terraform Enterprise for, and all of our tools we build in Enterprise, are the things we expect the Global 2000 is going to want. Things around for teams and organizations, it's collaboration, governance sort of concepts, and you'll see some of those today here. But we don't want to undermine our community and force everyone into Enterprise. We expect that there's always going to be a large portion of people using the open source. What we want to make sure is that we're providing enough value that at the point that you're collaborating with enough people and you need some guardrails around your system, you're going to choose to go to Enterprise to add that on top of what you already have. So Enterprise is offered in two different methodologies. One is SaaS and the other is on-premise. The code's very similar. The SaaS is what we'll be using today. So the workflow and all that, the interface looks the same for the Enterprise, for the SaaS or the on-prem. If you're running it on-prem, you'll have access to the admin tabs that we're not going to go through today. But that's so you can create multiple separate organizations. Because the on-prem is pretty much the same code as the SaaS, it means that you can run it at a multi-tenant sort of solution. And we increasingly see that organizations are adopting us at the central IT perspective, where they can provide Terraform as a service and Vault as a service and Console as a service across their organizations, whether that be managed by central IT. So that's something that for a lot of these larger shops, increasingly we've seen be common when we want to expect you guys to be thinking about how can we move this adoption from just individual BUs towards a larger play that's going to drive the entire business forward. So features, we get UI, easy integration with version control. We have API-driven workflow. We have plugins for Jenkins, and you can really use any CI tool with us. We do centralized state file management. One of the things we do with state file too. So as we mentioned before, state files often have secrets. We have Vault running under the hood in Terraform Enterprise, and we'll actually encrypt the state files with a key that's separate for each of the organizations before we write it to disk. So that means even if somebody had access to the underlying storage for Terraform and they had access to Terraform for a different workspace, they would be unable to actually get access to that state file because of how we wrap it up. So from a security perspective, there's a big advantage there versus trying to solve that by hand. People often don't have good security around the state files. From a potential internal malicious user. Private module registry, as I mentioned, the public registry is great for really generic stuff, but you may have things that's this is how we at ServiceNow deploy all of our Tomcat servers. Right? These are the standards that we go by. We can write a private registry module and share that and make it reusable and have the confidence that people are going to do it the right way. And then Sentinel, something we'll see today. This has been a huge driver of enterprise for us. This policy is code, and we'll dive more into that in a bit. Then we have single sign-on. This is for the private Terraform Enterprise that's on-prem. We can hook into SAML, and so if you got Okta or AD, I can tie that into these systems as well. And then I can manage variables and API keys in a secure way, so I can make those available to people to use without actually giving them access to have the raw keys, so they get access. So they have to put everything through Enterprise. They can't go access the portal themselves. We have something that we have been announced at HashiConf last year. We've had a closed beta, and it's going to go GA at HashiConf this year, called Terraform Cloud. One of the things we've realized is that state management is really a problem, not for just larger enterprises, but it's a problem everyone has. And we want to make sure that people are doing it well, because you can see from what we've done here today, we're storing the state files locally. If we lose that, it's really obnoxious in order to manage these systems again. And so there's a lot of different things we support for backends, from blob storage to Artifactory to DynamoDB, but we're just going to give people a free access to a free version of Terraform Enterprise. We'll call it Terraform Cloud. That's going to give you the ability to really provide that state file management. And then we'll have the ability for people that need it to buy additional features on top of that. Here. So we want to sign up for a free account. This is the link to sign up. We'll talk about exactly what I want you guys to do here in a bit. This is also in the exercise. When we get to the exercise, I'm going to ask you to create an organization with a particular prefix in it. Please do that so we can give you trials. So we'll create new organizations here. We'll create organizations that are separate sort of business units, and then you can add people to your organizations. I'm going to have each of you guys create an organization with a particular name, where it's going to be this prefix. And I'm going to actually put the prefix in Slack right now. Cap 021. That's the prefix. So everyone who create an organization, put cap 0621 at the beginning of it. What I need to do is I have to go on the back end and grant you guys all trials, and it's going to make it much, much easier for me to find all your organizations if they all have the same prefix. So remote state, talk about this a bit in the back ends, but this allows us to push the state up to the server. One of the difference between the regular backends and the remote state backend is that, unlike the regular backends, which always require that you still run Terraform locally, with the remote backend, we can actually cause the Terraform runs to look like they're running locally, but occur up on Terraform Enterprise. The nice thing is if I lose internet access now, I don't have to worry about this thing dying halfway in between. Credentials can be stored up there instead of on somebody's laptop that could potentially be lost or stolen. And of course, I've got the centralized record keeping for all of that. So here's how we configure this. First off, we need to create, it will create a token, and then we'll need to put that token to access Terraform Enterprise in a terraform.rc file in the home directory. So this is what it looks like for this token, the token in right here. And then inside of this Terraform folder we've been working in, we're going to want to create this stanza. You can put this in your main.tf, or what I recommend here is put in a remote backend.tf folder, the same stanza. Make sure this organization matches the name of the organization you created, and then you can name this workspace anything you want. After you create this, we'll run a Terraform init, and then you'll have a choice, and then we'll want to go and configure that workspace to use local execution. What this means is it's going to use Terraform Enterprise as just state file storage and not as where your Terraform is actually going to be executed from. We'll change it over to remote later, but to begin with, we want to do it local. So that's the exercise here, 1 and 2. Like I said, create your accounts. Make sure you use that prefix. It's cap 0621. and then your username or really whatever you want to put after that. Create an API key for your user, which you'll find under your user and settings. There'll be a token page. All the information's here. And then we want to configure that .terraform.rc file and add the Terraform configuration for the backend. And then when we run a Terraform init, like I said, you'll see that workspace get created and the state file get copied over. And then we can go and change that to be local execution. And you can run a Terraform plan applied, because we haven't changed any of the Terraform code for what we're doing. Nothing should actually happen, but we can see that it's executing. And then we can start seeing the state file stored up in Terraform Enterprise. So I'm going to give you guys 10 minutes to go through this. If you got any problems logging in or creating a workspace, please hit us up in the chat.
Hey, Chris, I can display a timer again. How much time do we have left? Like 8 minutes or so, or 9?
Yeah, I was going to like 7.
7? Okay.
Yeah.
I'll do that.
Thanks. All right, well, let's get going again. Let me share my screen and go back to here. Hopefully this is still logged in. All right. All right. So first we need to create a, no, I do not have one. I thought I already had one. I'm going to create a Terraform RC based on the syntax that we see here. And now I'm going to stop sharing so I can put my token in real quick. So hold on while I do that. Right, and I'm going to start sharing again because I've got, this is a token for a user which will not exist long. So share, here. My token. And now let's go back to my training folder. We're going to copy Hashi corp. Sit down. I don't need that. Let's do a Terraform init. See what happens. Now, it's not ls. Did I screw up that format? Credentials. All right. And so when you do the initialization, you should be asked, do you want to copy your existing state?
Good night. Take rest, okay?
Sorry, what?
तो मेरी तरफ से एक पार्टी रहेगा तुम्हारे लिए इतना इतना बड़ा काम के लिए
I'll find it. Hold on.
Sorry.
Thank you. And I've already done this one before, so I need to change my workspace name because it already exists. So let's change it to cool. And now I've successfully initialized. So now I should be able to go look at my organizations. And it's this one, CAP training, just created it. Nothing's come over here yet because I haven't really done anything. But I did push up a state file. And I'm going to go settings general. And we're going to change this to local and save settings. See, when I change this to local, I lose most of these tabs. It's really just about state storage at this point. We'll get the other tabs back here in a minute, but we got to get this going first. So, and now if I do Terraform apply, nothing should need to change. Hopefully, unless it broke again. And of course, something is hosed. What am I breaking? Let that go. And it'll go through everything it needs to do and then update the state appropriately. Well, we can talk about our next section. So we've now done state storage, but let's do something a bit more interesting. So protecting sensitive variables. So we've got these API keys that we need to access Terraform, or sorry, to access Azure. Because we're using the Cloud Shell is already authenticated with your Azure account because you're logged in. However, this is not a good production way to do this. It's a great proof of Microsoft's commitment to Terraform and an incredible convenience when you just need a shell, and great for these types of trainings, but I would not recommend using the Cloud Shell as your primary way to modify Terraform code. So you're going to need some other way to do that. And if you're doing it locally from your machine, you're going to be using either AZ login or these secrets. You never want this API key to be published, though. And if I'm doing this, if I want to have everyone ensure that it goes through Terraform, the best way to do that is to have a CI system, or better yet, Terraform Enterprise, actually manage talking to Azure. But I may not want to have everyone be able to see these credentials. And so what I need to do is have a way to put this information into Terraform Enterprise without people being able to come out here and get this client secret back out. And so that's where these environmental variables come in. And actually the whole Terraform variables page, we have this checkbox for sensitive, which means that I can mark this as a sensitive value that I can write in here, but people can use it, but they can't actually read it. This is very valuable for these APIs, things, passwords, TLS certificates, SSH keys, anything you really just don't want people to be immediately able to see. So first we're going to change it back to remote execution. And then we'll do our exercise, which is to configure the environmental variables for these secrets. When that credentials file that was shared at the very beginning, at the very top of that file is this information for a service principal that already exists that you guys should be able to use. So go in there, change yourself to remote, and then create environmental variables under the variables tab that match this information. And then you should be able to run another plan. You can either kick it off in the UI, or you can run Terraform plan locally, and it'll stream local while also running in the backend, and you can actually see what occurs. So let's give another, let's call it like 8-10 minutes for that. So it's like 11:18. We'll start going again.
Okay, timer is near ready.
Cool. Let me put my headset back on and we're going. Thanks for calling out the time.
It looks like we have a couple of people stuck as well.
Yeah, I'm just trying to respond to those questions. So a couple issues. If you see the configuration version is missing, sometimes we're moving from a local to remote. It hasn't loaded the configuration from your local machine up to the Terraform Enterprise. So try running Terraform plan and apply locally. After that first time, once you move to remote, you should be able to use the UI from then on. And I've also seen we have another issue where you get an error about error locking destination state, error requiring the state resource lock. I've had that issue in the past where I've just nuked the .terraform folder and run Terraform init, and it's fixed it. Looks like in this instance it wasn't fixing it for Michael. So worst case scenario, you can always blow away your local terraform.tf state file and rerun, which will, of course, regenerate new resources. Cool. Like I said, we've got people in the chat, so if you guys continue to have issues, please comment there. Let's share my screen and go through this here. So we want to change this workspace to be remote. We're going to save settings. Now we got environmental variables. Add. And let's go and look at my pins. We got the creds file. So ARM client ID. Copy. Save variable. Client secret, and this is the one we're really concerned about being sensitive. ARM subscription D. And then ARM tenant ID. And save this. All right, and I think I can get this configuration one too if I probably run it now. Yeah. So we're going to run it from command line here. Here from the net, I think we already got stuff. Do Terraform apply. And now when we do it, because I've switched to remote, you can actually see it's running in the remote backend and tells you that. And it tells you, hey, you've got that local TF state, which I should move out. And so, cool thing about the remote state is it actually gives you this nice link where you can go and see what's going on. So if you want to share that with your coworker, even though you're working locally, you're going to come back to it. You can see it in the UI here. And we can actually see it's going to go through on create that plan. And as it finishes, we see that changes are up to date. And we see my plan finished and apply is not going to run because there's nothing that changed. Cool. So let's move on to the next exercise. Sentinel, this is where this gets fun. So Sentinel is policy as code. This is our ability to say, so if you think 15 years ago, somebody created a change control ticket and said, I would like 1 million VMs. When a person opened that ticket, they would laugh and they would call the person up and be like, hey, that's clearly not going to happen. It's not how it works with automation systems. Terraform will attempt to deploy 1 million VMs. That would be either insanely expensive or it will break something, possibly both. Sentinel is our way as we're trying to enable more people to use Terraform code. We'll ensure that they don't cause problems, so they hurt themselves or an organization. We can write our policies in Sentinel and then have those applied at the plan stage before the applies actually run. So we're able to really control before things are happening to stop and make sure that they're not going to do something that's wrong. I think about alternatively, if I'm using the rules that are up in Azure to write policies, it's going to keep applying successfully until it runs into the thing that's problematic, and then it might barf at that point or throw an error at that point. Here we can stop the entire apply, knowing before anything occurs, knowing that, hey, that's not going to be allowed. We can also do some more interesting things because we have an understanding of all of the stuff that's inside of the Terraform configuration and plan, and we can see all of that and write whatever rules we want around that. Sentinel, by the way, applies to all of our tools, not just Terraform. It's an enterprise feature, but it goes on everything. So you can use it if you want to manage, say, a vault to ensure that the passwords are only changed during a certain time of day during production hours, or console. You want to ensure that only certain types of intentions are written. All of that can be done with Sentinel as well in each of those tools. Sentinel is an enterprise feature that bolts on to the enterprise each of those. So what we need to do in order to actually have this run is we need to destroy our workspace. The Terraform Enterprise, to actually destroy, you have to create an environmental variable called confirm destroy, or will not let you actually destroy. So we're going to go and do that when we get to the exercise, which is the first thing we're going to do. Is we're going to destroy that. Then we're going to create a new Sentinel policy. I've put the actual policy you want right here. What this is a policy to allow certain VM sizes. We want to create that policy. I recommend setting it as soft mandatory. Set it as hard mandatory. You won't be able to override. Soft mandatory is nicer to look at. And then we need to create a new policy and apply it to the workspace that we're doing our stuff, what we're doing. So let's go do that. I'll give you guys, let's call another 8 minutes until 11:35.
All right. Timer is done.
Great, thank you. Let's go through this one real quick, and then the last two bits and the last exercise. And hopefully leave a few minutes for questions at the end. So share my screen. And we want to destroy the workspace and then create a new Sentinel policy. So first off, here, I want to go to variables, add variable, destroy is 1, save, here, saving variable. That's interesting. Cool. So I confirm destroy. I could come in and hit Q destroy plan from here. I can also do it from the command line. Let's do it from here. Yeah, let's just say we want to destroy all of these items. Once this finishes, it should ask me to confirm. Nice thing here, you can actually see with the Enterprise, I've got an auto log of everything that happens. So I can see, hey, look, C. Madison triggered this to run. And now I can see, let's confirm and apply. I can put a note here, destroying everything. Confirm that, and then that ends up in the log history of why this happened. So this is a little bit better than, you can look at if somebody makes changes to the the code in the VCS repository and do git blame and talk about at the beginning, but actually seeing who triggered the runs and knowing that I saw the plan first, that's always good to understand exactly what occurred. So this will take a minute. While that's going, we're going to go create these policies. So settings, policies, I can create a new policy, and we call it allowed VM types. Call it really anything we want. Just mention, set to soft mandatory. Let's get that code that Ryan was nice enough to copy and paste into the chat, and I can dump it in here. By the way, so advisory is going to give you a warning. Soft mandatory.
You missed, sorry, Chris, you missed the I on the very top.
Oh, thank you very much. Cool. I appreciate that. So soft mandatory means if I set somebody as an admin on the workspace or an owner on the workspace, then they can hit override. So we can think about this like giving a manager permissions, where I'd give the regular users on a team only the ability to trigger runs. I'd give the manager the ability to be an owner so they could override these kind of things. And then hard mandatory means somebody would have to come in here and change this policy in order to apply that. I don't have any policy sets yet, so we're just going to create the policy. And let's go create policy sets. So let's call this app training. We can enforce across all workspaces, so probably create some global stuff, or we can apply to specific workspaces. I'm going to add the policy here, and then I'm going to add the workspace I want and create the policy set. And so now we're applying this policy against this workspace. So this is still in the process of destroying. Whenever this gets done, we'll be able to trigger another plan, which will cause this to trigger again. And it will cause it to be evaluated for Sentinel. I'll come back and look at that once this finishes, because it's slow. So let's talk about version control. So everything we've done today is using the API and the command line to push your code from locally up to Terraform Enterprise. Again, that's really useful for testing like this. It's also nice if you have an existing CI pipeline, or say you're using Jenkins and the Docker container for Terraform, to actually run Terraform, but now you want to integrate that with Terraform Enterprise. Well, instead of going through and rewriting it to use a Jenkins plugin, I can simply add this backend information, and then the same workflow I was using before will continue to work, but it'll actually be running through Enterprise. But most of the time, we're going to expect that in production, you're going to want to trigger this, tie this up to your version control system. So how do we do that, right? So your operators, instead of pushing code straight to Terraform with how we've done it here today, they'll probably push that code. They'll develop locally, have local state files, and once they're ready, they can do pull requests against a repository or a branch, which is tied to Terraform Enterprise. And when that occurs, that can cause Terraform Enterprise by default will automatically trigger a plan from that new code that was configured. We do that hook into the version control repositories. So if you've got really any Git-based workflow, we make that really easy to do out of the box. For non-Git-based ones, we need to use the API or another method to pull it in. So we'll trigger that plan automatically, and then you can set it to either automatically apply or require somebody to come in here and do the apply. And you can even get information back about, like you see here, in my CI, in my VCS system, right? Like this is exactly what's going to happen with that plan and my policies that were passed. So you can allow people to merge based on that. So this, again, infrastructure as code, you really have to put in version control to really get the benefits of this. If you're just using Terraform code raw and you're not putting version control, it's only slightly better, if better at all, than just doing things in a UI. We can merge with VCS, so collaboration. I can use CI tools like Circle CI, Jenkins, etc. And that's really helped me if I want to tie multiple repositories together and potentially put some automated testing on that as well, code reviews, other steps. CI tools are a really important step for that. And we've got also easy integrations with most of the CI tools that are out there. People have definitely used pretty much every CI tool you can think of with Terraform in the past. So as VCS, we are not going to do an example of that today because we'd have to set up a whole bunch of stuff. But good to know that for if you guys are doing this production. The very last chapter we've got and the last exercise is on access controls. So we have role-based access controls based on you can create teams and then you can add people to those teams and then you can assign permissions to those teams so they can collaborate in the UI and see other workspaces. So, of course, didn't rename that one. I think I did rename it. I just had it refreshed. Do 10 exercise. So this is one, if you guys can take the usernames that you had created for Terraform, paste that into the training chat window, and I want you guys to create a new team, and then add your coworkers as members of your team, and then grant them access to your repositories. Doesn't necessarily have to be write access. You can give them read access or whatever you want, but give access to your team members to your repository so they can see the actual workspaces that you have. And then you'll notice when somebody grants you permission to those workspaces, when you log into Terraform, you'll actually see those new workspaces up here, and they'll be able to switch over to the new workspace, the new organization, the new organizations up here. You'll be able to switch to the new organization and then see the new workspaces that you were given permission to. So this is our last challenge, and then we got a couple wrap-up things to talk about after that, and a survey that I want everyone to take so we can get some feedback. So I'm going to give you guys another, let's give it, let's call it like 4 or 5 minutes, 11:59, then I'm going to do the wrap-up stuff, and I want to save a few minutes for questions at the end. If anyone else is sitting on a destroy plan taking forever, I've seen it fail sometimes where it seems like it actually got destroyed, but for some reason it's gonna wait till time's out. You can cancel the run and trigger it again, and hopefully that should allow to finish it that time. All right, looks like we're back. Let's finish up real quick. As I mentioned, there's some bug I hit with the virtual machine destroying in TFE. And figure out what's going on there, but you can cancel it. It's actually already destroyed and just rerun and destroy to get rid of the rest of the resources. And then once you've done that, you should be able to redo the rest of it. I'm just letting that finish now, and so I can show the actual Sentinel piece. Let's share my screen and look at the survey here. So now that we have shown you, like I said, just a lot of Terraform, a snippet of the Terraform Enterprise bits. There's a lot more pieces to this, right? Best practices and other conversations that I'm more than happy to have. How we operationalize this, bring this to the greater teams. There's a lot more, hopefully, you can see where we can go from this, but my hope is this kind of inspired you guys to see the power of what we got here and get you going with Terraform and Terraform Enterprise. Before you guys leave, please do a Terraform Destroy and kill anything that you've got. This helps us reduce our costs, and I'm going to delete all of it eventually anyways. I may not delete it right away in case anyone's still working on some of the exercises, but if you're definitely done, just destroy it. Those credentials you've got for Terraform Enterprise will be good for a month. You can create a new organization if you don't want your organization to be named with that prefix, or you can just keep it. Actually, the trial's based on that organization, so you should work with that one. But you get another 30 days if you want to play around with that. But please destroy the stuff that you've got running up in our Azure portal. Finally, we have a survey. Of course, that link did not copy properly. I'm going to put that in the Slack, and I'm going to pin it as well.
Yeah. And please take the time to take the survey. It's only a few questions long, but it gives us great feedback on how to improve these in the future and what types of content that you're interested in as well. So
yeah, also I'll add too that, everyone does need to do the survey because if you don't, we can't continue to do these, right? So, we just need to make sure we get that feedback from everyone to encourage us to, continue to do these types of things with HashiCorp. So even if you watch this as a recording, by the way, do the survey too, like if it's within the next couple of days or whatever.
Thank you.
Cool. Thank you guys. And at the end of this, if you look at the deck, there's some additional resources and links. So that's all I've got here. Let's see if this thing finished so we can actually run it again. Yes, it did destroy, so I'm going to queue a plan. And this should actually show us the Sentinel piece working. So in the last 8 minutes or so that we've got, will we let this thing run? Is there any other questions people have? Other things we want to discuss?
Well, I did just hear a survey wasn't loading for someone, but we want to double check that. Oh, I guess it is working. Okay, we'll have them try again.
Cool. If it keeps not working, let me know. I may be logged into Survey Monkey. All right, so I triggered another plan, make these resources, and you can see Sentinel triggered. Because we're using an A2 and that only is allowing A1 or A0, you can see that it's failed this policy. I have the permissions to override, but if I didn't have the permissions, I'd have nothing I can do here except to start this run. So you can see a great way to really allow you to maintain what people do. You can also allow people that even if they don't have permissions to override, they could leave a comment. I could say, manager, please override for me. And that way you can have that conversation, that whole history baked in here. Cool. I said, any last questions? Hopefully you guys found this useful. Please, any feedback you guys can put in the survey. We definitely want to improve these going forward.
Well, so is this open Q&A now, Chris?
Yep, if anyone's got anything.
I guess no questions then, so.
Sorry, I got one quick question. I think we had touched on this in the beginning, Sekou, when you asked about the deployment proof. When you deploy a resource group and you can check the deployments in a resource group, for some reason it doesn't show up when we do Terraform stuff. So two things. One, how can I see the ARM template that Terraform is creating, assuming it's creating one behind the scenes? And then from the portal, how do I tell if that something was deployed?
So Terraform doesn't so we can use ARM templates, but I really highly discourage it. And this is one of the things that's confusing, is we use ARM. So ARM is the Azure Resource Manager, is an API, and then ARM templates is their methodology that uses that. We also use ARM, but we do not use ARM templates. So you're not going to see like the ARM template deployments in there. We're talking straight to the API and telling it to create those resources.
Oh, I see. So you're just calling the rest straight up.
Yep. And the whole advantage of that is if you use ARM and you do a deployment and you want to update that, it's really a pain. And if you want to delete like an individual item, it's a huge pain. Where we can manage individual items, update them. We can do it across subscriptions, which ARM templates can't. There's a bunch of limitations to ARM templates that we get around because we talk straight to the API.
Okay, so there's no way to audit what was happening from the portal. I ask this because I have clients that are trying to be cloud native, and they only use Azure. So they have, say, for example, like security center setup, Azure Log Analytics, etc., where they set everything up to monitor what's going on, and the teams are trained to go in there and check and verify things. So if we're using Terraform to do deployments or creations, deletions, etc., how does someone audit what's going on?
So I think we talked about this earlier about turning on additional auditing, and you can actually see that Terraform pulled it through. Our real preference would be push everything through Terraform Enterprise, and then you'd have that audit history in Terraform Enterprise.
But there's nothing native in Azure that shows me what's happening.
Yeah, I mean, within Azure itself, like if you look at those resources, like each resource will have an activity log.
Yeah.
But it doesn't show you a ton of information there, right? It will show you at the beginning which account requested it be created. But if that's a service principal, that may not be very helpful.
Okay, I see.
Any other questions?
Okay, well, if not, thank you very much for this session. This is recorded, so we'll post that for people to watch later if you need to go over this at your own pace. Thanks everyone for attending.
Thanks.
Thanks.
Thank you, everyone.
Cheers. Bye.
Thank you. Bye.